Hey everyone, and welcome to The Explainer. Today we are diving into one of the biggest, most frustrating problems in all of AI. How do you teach a robot to learn new things on the job without it completely forgetting everything you just taught it? Let's get into it.
So let's start with a simple question. What actually happens when a robot in your home or at a factory bumps into something it's never, ever seen before? I mean, it can't just throw its hands up and quit, right? Its ability to handle the unexpected, the new, the weird, well, that's everything.
And that leads us straight to this huge dilemma. It turns out even the smartest, most powerful AI models out there have this critical flaw. It's like a kind of digital amnesia that can strike the moment they try to learn something new.
And it has a name that sounds just as bad as it is: catastrophic forgetting. Seriously, when an AI learns a new skill, the neural network inside its brain has to change and adapt. But in doing so, it can literally overwrite and completely erase a skill it had already mastered. It's a huge problem. Here's a way to think about it that really hits home. Imagine you spend a year getting totally fluent in Spanish. You're amazing at it. But then you wake up one day and realize you've completely forgotten how to speak English. That's the risk for an AI. Every single new lesson could wipe out an old one, which makes learning over a lifetime feel almost impossible.
So, is that it? Are we just stuck? Well, maybe not. A brand new research paper has introduced a potential game changer, a new framework designed to beat this exact problem. Everyone meet CAPA-AI.
Okay, yes, it's a bit of a mouthful, I get it, but the name actually tells you everything you need to know. It's cognitive and agentic, which is just a fancy way of saying it can think and act on its own. And the magic is in the probabilistic adaptation part. It uses math and odds to figure out how to adapt to new stuff. So how does this whole thing work? It's actually a pretty elegant two-step process. First, in what's called isolated learning, you train the AI in a nice, safe, controlled digital world. You give it a solid foundation of skills. But then comes the real test, the adaptation phase. You drop it into the messy, unpredictable real world and tell it, okay, now learn on the fly. And this really shows you just how different this is. The old way, you had to retrain the entire AI from scratch for every little new thing. It was slow, super inefficient, and you always had that massive risk of catastrophic forgetting. But the CAPA-AI way? It's built to adapt constantly. It reuses and repurposes its old knowledge to understand new things. It's faster, way more efficient, and most importantly, safer.
So what's the secret sauce here? What makes it tick? It all comes down to a really simple but powerful idea. First, you detect if something is new. And only then do you figure out how to adapt. That careful, deliberate logic is the key that prevents it from just overwriting its own memory.
It all starts with just seeing. The robot's camera grabs a picture. Immediately, a vision AI called Lava turns that picture into a simple text description, like a person is drinking from a cup. Then another AI, DeepSeek, jumps in and boils that sentence down to just the most important key words.
And look at what this creates over time. For a simple task like drinking, the AI doesn't just know that word. It builds this rich cloud of related ideas. It's seen drinking 1,900 times, sure, but it's also connected it to coffee and cup and glass. It even adds context, like chair or stairs. This is how it builds a flexible understanding of the world, not just a rigid dictionary. Now, when the robot sees something new, it does the same thing. It extracts keywords. Then it pulls out some pretty cool math, using things like conditional probability and something called the Jaccard index. I know, that sounds super technical, but all it's really doing is calculating a similarity score. It's just answering one question. How much is this new thing I'm seeing like something I've already learned?
And that one score drives everything. It's a simple decision tree. If the similarity is over 90%, the AI is confident. It basically says, oh yeah, I got this, and just uses a skill it already has. If the score is in that middle zone, 60 to 89%, it thinks, this is new, but it's kind of like that other thing I know. So it adapts, using a cool technique called transfer learning. And if the score is low, below 60%, it knows this is totally new and it's time to explore and learn from scratch.
Okay, this all sounds fantastic on paper, but you know the real question is, does any of this actually work, like in the real world? Well, to find out, the researchers put CAPA-AI to the ultimate test on a real, walking, talking humanoid robot. So here's the setup. They took the CAPA-AI brain and loaded it onto this humanoid robot called Ari.
Then they put it in a room with a person for a 30-minute session. During that time, the person did a bunch of different things. Some stuff the robot had been trained on, and some stuff it had never seen before in its life. The test was on, and the results were honestly so cool. When the person drank some water, the robot nailed it, recognizing the familiar drinking task. But then, when the person used a tissue, something totally new, the robot correctly saw it as novel, but then brilliantly connected it to its cleaning skill. When someone else lay down on the floor, same thing. It saw the novelty, but smartly related it to its knowledge of sitting down. This is real adaptation happening in real time.
Let's put some hard numbers on this. In all their simulations, CAPA-AI was able to spot a new, unfamiliar situation with an incredible 89% accuracy. That is a huge first step.
But simulations are one thing. The real world is messy. So how did it do there? Get this. It still achieved an 80% accuracy rate at adapting to new tasks. This proves it's not just a fragile lab experiment. This thing is robust enough to actually work.
Okay, so this is a really big deal. This is a major step forward. So what does it all mean for the future of, well, everything?
Look, this isn't just about making a smarter robot for the sake of it. This is a fundamental building block for creating robots that can actually be helpful, autonomous partners. A robot that can learn on the job without forgetting what it knows is a robot that can finally work safely and effectively in our homes, our hospitals, and our factories.
Now, of course, the journey isn't over. The researchers are super upfront about the challenges that are still ahead. For one, the more the robot learns, the bigger its knowledge base gets, and that can slow things down. And language can be tricky, right? Is using a tissue really the same as cleaning? These are the next tough nuts to crack. But as the researchers themselves conclude, what they've built here with CAPA-AI is a powerful, practical foundation to build on. They've proven that creating an AI that learns for a lifetime isn't some sci-fi dream. It's an engineering problem, and it's one we are actively solving right now.
So we just saw a system that can learn new tricks without forgetting the old ones. That means the conversation is shifting. It's no longer a question of if we'll have robots that can learn and adapt in our world. It's just a question of when. Thanks for joining us.